Welcome to the world of Python data structures. In this video, we'll demystify four fundamental structures: lists, tuples, sets, and dictionaries. These are the building blocks for organizing and managing data in Python. They are essential for everything from simple scripts to complex AI applications. Each data structure has unique properties that make it suitable for different tasks. These data structures are used across diverse applications in Python programming. Understanding how these structures work in memory is key to becoming a proficient Python programmer. Python data structures can be categorized as either mutable or immutable. This distinction is crucial for understanding how data is handled in Python. Mutable structures can be modified after they are created. Immutable structures cannot be changed once defined. Mutable data structures include lists, dictionaries, and sets. Immutable data structures include tuples, strings, and frozen sets. Let's look at a detailed comparison between mutable and immutable objects. With mutable structures like lists, we can modify the content by adding or changing elements. Immutable structures like tuples don't allow modifications after creation. Attempting to modify them will result in an error. This example shows how even in a tuple, if it contains mutable objects like lists, those lists can still be modified. Understanding the mutability of data structures is essential for writing efficient and bug-free Python code. This distinction will be particularly important as we explore each data structure in the upcoming sections. Next up are tuples. Tuples are ordered collections of items, similar to lists. However, the key difference is that tuples are immutable. Once created, you cannot change their contents. Tuples use parentheses instead of the square brackets used for lists. Like lists, tuples are ordered collections, and you can access elements using indexing. The first element is at index 0. The defining characteristic of tuples is their immutability. Once created, you cannot modify, add, or remove elements. If you try to change a tuple element, Python will raise a type error. This comparison shows the key differences between lists and tuples. Lists use square brackets and are mutable, while tuples use parentheses and are immutable. Tuples are suitable for representing fixed collections of data. Common use cases include coordinates, function return values with multiple items, database records, and as dictionary keys when needed. Tuples are immutable data structures in Python, which means they cannot be changed after creation. This immutability offers several important advantages. First, it ensures data integrity by preventing accidental modifications to your data. Second, immutability leads to performance improvements in certain scenarios, particularly for operations that involve hashing, like when tuples are used as dictionary keys. And third, immutable objects are thread-safe by nature, making them ideal for concurrent programming without needing locks or other synchronization mechanisms. Let's see what happens when we try to modify a tuple. We create a tuple of coordinates, but if we try to change any value, Python will raise a type error. This error occurs because Python enforces the immutability of tuples at the language level. The internal structure of a tuple remains constant throughout its lifetime. When should you use tuples? They're perfect for representing fixed collections of data that shouldn't change, like coordinates, date records, or RGB color values. Tuples offer advantages over lists in terms of integrity and performance. When choosing between them, consider whether your data needs to be modified after creation. Understanding immutability is crucial for selecting the right data structure. Tuples are just one of Python's built-in immutable types, alongside strings and frozen sets. Sets are highly efficient for membership testing, which is checking if an element exists in a collection. In Python, we use the in operator to check membership. Let's compare how membership testing works in lists versus sets. When we search for an element like elderberry in a list, Python needs to check each element one by one until it finds a match. But with sets, Python can check membership almost instantly, regardless of the set's size. The reason sets provide faster membership testing is due to their internal implementation. Sets use hash tables internally, which allow them to organize data for immediate access. Some implementations may use balanced binary search trees or similar structures. When comparing performance using big O notation, we see that list membership testing takes linear time, meaning the time grows proportionally with the size of the list. Set membership testing, on the other hand, takes constant time, making it much more efficient, especially as the collection size grows. Sets are ideal for practical scenarios where you need to quickly determine if a value is present. Common applications include checking for duplicate usernames, filtering unique elements, or performing set operations like unions and intersections. To summarize, sets provide significantly faster membership testing than lists, especially for large collections. This makes them ideal for scenarios where you frequently need to check if an element exists. Finally, let's dive into dictionaries, one of Python's most powerful data structures. Dictionaries are collections of key-value pairs, where each key maps to a specific value. Here's a Python dictionary example that stores information about a person. Each key in a dictionary must be unique. If you try to add a duplicate key, it will override the existing one. Dictionary keys must be immutable objects like strings, numbers, or tuples. This is because dictionaries use a technique called hashing to provide fast data retrieval. Dictionaries are mutable, which means you can add, remove, or modify key-value pairs after the dictionary is created. This key-value structure makes dictionaries ideal for representing real-world data where items are accessed by a specific identifier rather than position. Unlike lists and tuples, which are accessed by index, dictionaries use keys to quickly retrieve their associated values. Dictionaries provide extremely fast data retrieval based on keys. Unlike sequential data structures like lists, dictionaries offer constant-time lookup performance regardless of their size. This speed is achieved through a hashing mechanism. Each key is run through a hash function that tells the dictionary exactly where to find the value. Unlike lists, where you might need to search sequentially, dictionaries can jump directly to the data. This makes them perfect for scenarios where you need to quickly look up values based on unique identifiers. Consider a real-world example: a customer database with millions of records. A dictionary can retrieve a specific customer's data instantly using their unique ID. When comparing time complexity, dictionaries outperform lists for search, insert, and delete operations. While lists require linear time for searching and deletion, dictionaries perform these operations in constant time. Even with large and complex datasets, dictionaries maintain their excellent performance. This makes them indispensable for applications where speed is crucial, such as in data processing, caching, and API responses. Here's a practical code example. Searching for an item in a list of 1 million entries requires checking each element until the match is found. With a dictionary, you can access the same item instantly, regardless of the dictionary size. To summarize, use dictionaries when you need fast lookups based on unique keys, especially when dealing with large datasets where performance matters. In the realm of artificial intelligence, Python's core data structures are indispensable tools. AI systems must process massive datasets efficiently. The right data structures make this possible. Let's explore how each of Python's core data structures is utilized in AI applications. Lists store sequences of training data, model weights, and input batches. Tuples hold fixed data points, immutable hyperparameters, and dataset schemas. Sets eliminate duplicates, aid in feature selection, and track unique categories. Dictionaries map features to values, store named hyperparameters, and create efficient lookup tables. Dictionaries are particularly powerful in AI for mapping features to their values. They provide constant time lookups, making data retrieval extremely efficient. In AI systems, dictionaries commonly map words to embedding vectors, feature names to importance scores, and model parameters to their current values. Efficient data structures are critical in real-world AI adoption. As organizations increasingly implement AI solutions, these fundamental Python tools have become essential for managing complex data flows. Python's core data structures enable efficient processing at AI scale, form the foundation of data pipelines, and support both model development and deployment. Let's examine what experts say about Python's data structures. Experts agree that lists are the easiest way to store a collection of related objects and are easy to modify. Tuples are considered ideal when you need a data structure that cannot be modified by mistake. This distinction between mutable and immutable structures is fundamental to Python programming. Sets are highly valued for duplicate entry removal and efficient membership checking. Dictionaries are praised for enabling quick data retrieval based on unique keys. This comparison table summarizes the key characteristics and use cases for each data structure, as highlighted by industry experts. It's worth noting that both sets and dictionaries provide excellent performance advantages over other data structures for their specific use cases. Understanding these expert insights can help you choose the right data structure for your specific programming needs. Conclusion: Mastering Python data structures. Congratulations! You've now gained a solid understanding of Python's core data structures: lists, tuples, sets, and dictionaries. These four data structures differ in key aspects such as ordering, mutability, indexing, and how they handle duplicate values. By mastering these concepts, you'll be equipped to tackle a wide range of programming challenges. You now understand how each structure connects to one another and when to use each one for optimal results. Understanding memory allocation and optimization for data structures will help you write more efficient code. Continue practicing with these structures to become a more proficient Python programmer. By mastering these fundamental building blocks, you're well on your way to Python expertise.